But mutations are not the hero of the plot. What's a mutation? A mutation is a mistake in the copying of the genetic code. It's taking the recipe on the box and it's scrambling the letters and then trying to follow that new recipe to create the new cake. Well, you do that biologically, and there's some very small limits that you're playing with there. And what happens most often is that mutations are harmful or neutral. If you take your eye, for instance, your eye has a little molecule in it called the rhodopsin molecule, which is the light-sensitive part of your eye, or one part of it. And that has 348 chains of amino acids, 348 slots. Each one has a 1 in 20 chance of being correct. Well, there are some that carry a genetic mutation that changes 4 out of the 348 amino acids. Just 4 of them. It switches them out with different ones. And it causes a hereditary blindness in a lot of people. In fact, a lot of people of Irish descent carry this mutation. Just 4, and people are going blind. So there's not, the proteins are very specific structures. How many of you would say, you know what? I don't see very well. I need corrective lenses. So I think I'll subject myself to a 1% random change of the molecules within my eye to see if that makes me see better. I don't think we would do that because random processes are not good engineers. They make good destructions of things. They destroy things. They degrade things, but they don't create things. They're not good engineers. A few years ago, there were some experiments done to see if we could mutate animals and see where that would take us. And so what they did is they took fruit flies. Don't you love fruit flies in the fall? It just comes like a migratory feast of stuff in your house. And they took these fruit flies and they took the male of the species and they fed them mutagens, so food that would mutate their offspring. And then they would breed with the females and out would come mutant fruit flies. A lot of these experiments are in the textbooks. And they found a couple things. One, the mutations were real. They would happen. In fact, we have a picture of one here. The one on your right shows legs growing out of the face of the fruit fly. Yeah, I mean, if you were the fruit fly, you'd say, hey, I want a do-over. You know what I mean? This isn't working. But here's the thing, and if I can explain this well, it's pretty recent research they found. The Nobel Prize in the early mid-90s went to these folks. Is that while an organism is developing, there's a set of regulatory networks in your genetic code. So they used to think this was junk DNA, but it's not junk, it actually matters. There are certain parts of your genetic code that code for specific proteins. Your hair and nails. But the largest part of your genetic code is the one that tells when things need to be built when. It directs the timing of when these structures are built. Anybody ever wired a house before or built a house before? Did you wire the house after the drywallers? No, you don't want to do that. That would be dumb. See, there is what's called a general contractor that says, hey, let's do the groundwork, let's lay the foundation, let's build the frame it in, and then we'll get the wiring in so the guys don't have to, but then there's drywall, and then the shingle, all that stuff. There's a timing to building stuff, where if you get that messed up, it doesn't work. And it's the same thing with living things. There's a timing to building stuff. And so they took these fruit flies, and they mutated different parts of the genetic, the regulatory network, the general contractor. And what they found is the mutations that occurred early in the embryonic development caused the biggest change of the body structure. Early mutations are strong mutations. So if I wanted to mutate something, I'd want to radiate it early in the process. And so it would create big changes. The problem was, the hope is, hey, we need big changes to make the cow a whale. You need big changes, right, to turn a car that produces milk into a submarine that gives live birth under salt water. Okay, those are big changes. Well, I want big changes, and if mutations are the hero, I want them early. But what they've done with fruit flies and now other organisms is that when they mutate them early in the development, it's almost always fatal. It creates big changes. It kills it. That's an evolutionary dead end. So early mutations are big but fatal. In fact, they call it embryonic fatal. So the mutations that happen later, you got a car at the very end of the assembly line, or a house at the very end, and you say, do I want to paint it pink or red? It's not going to change it. It'll still function. Or maybe I want to put motorcycle tires on the car. It's going to degrade the operation, but it's not going to kill the organism. That has to be done late in the assembly line process. And so the way it's designed, and this is why we have these fixed limits on species or on family orders, that the early mutations kill it. They're big but kill it. The late mutations can happen, and they don't kill it necessarily, but they degrade it, or it's not big enough to make it into a whale.